This is my presentation for my design build classroom that I wanted to do. The importance of design build in technology engineering design is it allows us to take all of the components that we learn in Tech Design 1 or Technology Engineering Design, Tech Design 2, which is now TED 2, and the newest version that we have at Ragsdale High School, which is Technology, Engineering, and Design 3, which is honors course. So now we have to have these students take the skills they've learned in 1, the skills they've learned in 2, and they got to combine everything and really show how they can utilize this classroom online. So identifying the need, I said that Ragsdale, we have an aging infrastructure at Ragsdale. We have a whole bunch of things that need to be replaced. And typically you would use county money or you would use the school athletic budget to replace some of these things. But I think that we're losing a valuable possibility to teach and let these kids learn a little bit about engineering and design, and then maybe even building things. And they can use all of these different vocabulary words and all these different ideas and concepts and put them in one big place to do one big project, to see one big thing come to completion that's not just popsicle sticks that are glued together. I love all of our projects that we do, but I want them to see real world application for how things work. So we've talked about this in our department, and we feel like a larger project of a larger scale that they can see as a completion and something that is not just them taking it home and putting it on the refrigerator or on a shelf, but actually driving by it maybe as they graduate or after and seeing that things are done and that they had a part in that. That's a big deal for us. All right, so what needs to be fixed? We've got sheds. This is a press box up at the baseball field. It's rotten through the floor. The walls are falling apart. We've got the exact same thing happening at the softball field. There's little tiny sheds, $2,000 to $4,000 projects that need to be done at all times. Everything has a hole in it. Everything has something wrong with it, and it's not really a testimony against our athletic department. It's a complete and utter description of what schools are like today. They have issues, and there's just not enough money to go around. By the time you pay for the students to do X, Y, Z and the uniforms and all these things, there's not enough money to pay for all of these things that are old and aging infrastructure. Everything needs to be fundraised and replaced. So we've got football sheds, softball dugouts. Both are old. They were middle school dugouts that need to be replaced. They're falling apart. Why do they need a project, right? So why do the students need a project? You can see I put some pictures up at the top here. We've got technology. We're doing bridges. We're building bridges with popsicle sticks. Very cool. We get to see which bridge lasts the longest. We've got one that we use with circuit boards where they get to use diagrams and follow wiring diagrams to make certain things happen on the circuit board. The noodle project is always a very fun one where the kids get to try to design with very limited resources, something that can make a noodle tower stand up with a marshmallow on top. The kids love it. They love to eat the marshmallows. And then this one, which is behind my smiling face here, which is the robotics stuff that we had for when we had a robotics club that the kids get to actually use and incorporate into doing little small, simple tasks. So those are great projects. We love doing those projects. The problem is that they're individual and they're very specific based on what they're doing. So in the bridge project, they're kind of working together and putting things together to figure out if the design works. But in the end, if it fails, everybody claps and moves on with their life. And we see how far the bridge works. But we want them to see something through to the completion, right? To where it's not failing. The electrical thing is great. They get to follow exact, precise, kind of complicated instructions. I've even done that one. And it's a really actually fun lab, but at the same point in time, it's literally just instruction-based doing something, and they get to completion and they move on. The tower, actually, we do that in 2 days. They get to do it the first day with just the noodles and the structure, and then the next day they get to improve on the day before's tower design and see if they can go even higher, see if they can learn from what they did. But again, it's something that's destined to fail, something that's destined to do whatever. And, you know, you can even see, I got a kid in the background recording it for me, right? And he's got his headphones in, and he's not really necessarily completely checked in and involved because, again, some of these projects are hard for everybody to be a part of. So design, build, classroom. Impacts, what are they going to learn? Right? Who are we going to impact? What are they going to learn? They're going to understand materials. They're going to understand how they're consumed, where we get them from. We want them to know where their materials come from, the source, right? Are we going to get them from Lowe's? Are we going to get them from a local store, which is what we're going to source things from local businesses so they can see how it impacts the community and actually making connections with our community. Environmental impacts, we're going to do, instead of connecting it to, because some of these places are remote, instead of connecting it to the electrical system, we're going to try to install solar panels so it can be off the grid power. Students can see how we can power something off the grid. Economical impact, money, right? The school's money is a big thing. It's very important to see that we can save the school money. And, oh, by the way, by sourcing it from your local stores, you're adding to the community and you're keeping the community going, local business. Budgeting, they get to see how budgets work. That's very, very big for them, especially students these days. They don't know what a budget is. Political impact, right? We have to deal with authorities. The principal, the athletic director, they have to give us permissions to handle things. Building codes and regulations, you can't just do whatever you want to do. It's very important that you do what you're allowed to do, and how it affects us is what's been done in the political arena that tells us the rules and regulations that we can go by. Social impact, improvement to the school, improvement to themselves, right? Overall athletic process, cultural, right? Again, pride and ownership in a project for the school, right? And relationships built with the surrounding community, right? All of these things, there's every impact you can think of, there's 5 of them, but every impact you can think of in technology, we're trying to cover so we can let students see how this affects other things. Deliverables. So I did a word cloud. I made a word cloud and put it on here. You can see there's quite a few of the terms that we use in class. The point of this is to tie everything together, and that's why I wanted to put a word cloud on here. Obviously, the biggest word is optimization. We're going to make a process and see if we can make it work as good as we possibly can, working within the criteria and constraints, right? We're going to use terminology such as drafting and teamwork and design. We're going to deal with the environment. Engineering is the overall idea, right? Troubleshooting, big deal. Troubleshooting and problem solving. When we come to an issue, how do we fix it? You can't just shut down. You have to keep moving. We have to be able to fix things and keep moving. Life is not about stopping. Life is about keeping on going. And that's what we have to end up doing. Impacts, right? Finishing development. Systems and subsystems are one of the biggest things. We'll talk about that here in a second. Systems and subsystems, buildings of different natures all work together. They have different subsystems that work together with the system, and each subsystem has its own set of subsystems, so we can see how all the different things work together in conjunction, and there's always a subsystem to a system. It always works that way. So the needs. We obviously need tools, drills, hammers. We needed funding, so I started to look at what were the solutions. Donations, private funding, right? CTE funding, school funding, athletic department funding. Ultimately, I think that stuff that we're going to keep forever is going to be private funding. I know that's kind of a different thought process, but I think private funding is probably the best way to get certain things. That way it belongs to the department and not somebody else. Funding for building supplies, that's going to come from the people that are benefiting the most from this, the athletic budget, and possibly fundraising. We're going to see if we can get D.H. Griffin down the road, has done some of the largest demolition projects in the world, to see if they can chip in and help us out. Permission, right? We need to figure out who's going to give us permission. The parents have to let us do this. The administration has to let us do this. We, as a teacher, right? Mr. Riley and I, the 2 teachers in this arena, we're having to be the authority and the kind of expertise on this project. And the good news is we both come from a construction background. I was a construction engineer for Skanska Construction for about 5 years. And then I was a surveyor before that. I did a lot of heavy duty, big time construction. Mr. Riley worked in electrical engineering and construction. So we have the background to help out with some of this stuff. Building codes and permits, we know what that has to be. Safety and equipment training, right? That's coming from us. We're going to have to teach kids how to be safe and how to be able to handle certain equipment in a certain way. Building instruction, again, coming from us. And then, as I said before, we are the qualified instructors. Classroom delivery. So then I did a layout of how it would work. The issue with this particular project is going to be that we're not sure how it's going to go because I've never done this with a class ever. So we have to really, really, really try in the first semester, maybe even two, to test out little parts of this to see how it works so we can do it in the third or fourth semester in grand scale. Because like I said, we have plenty of things to build, but I need to make sure that this process is completely nailed down, no pun intended, so when we get to the point of doing everything in mass, that it actually flows and we get done, because I don't want to get to the end and the students don't have anything to look forward to or have anything to celebrate. So we do planning. I've initially decided that we're going to do planning and research for the building in weeks 1 and 2. So when the students get there, we'll introduce ourselves and we'll start to assign some roles and say, what do we want to do? How do we want to do it? And then as we're doing some of these sections, we're going to be going over and reiterating the terminology and the things that we want to do and making them apply to what we're doing. So brainstorming, needs, and wants, you can see on this, they're in bold. The things that we need to do, criteria and constraints, the most important 2 words in all of technology, engineering, design. What do we want to do and what are we allowed to do, right? So what can we actually do? The weeks 3, 4, and 5 are design. So the students are going to work on designing the structure. They're going to work on doing some drafting. We have a section that we do in Design Tech 2 that is them doing some drafting of, we do layout of the cafeteria and make sure that they understand how to draw things to scale and give me a scale model of every 78 tables in the cafeteria and and how everything fits on a map. So we're teaching them how to do drafting and how to do dimensions and numbers. We also do another one on measuring things. So design, drafting, planning, and blueprinting. And then we're going to reinforce how we can make measurements work and how you can actually make a plan agree with itself. Because the biggest thing is all the numbers on the plans don't matter if they don't agree with each other. And then we get to build element lessons. So we're going to talk about all the things we're getting ready to build. We're going to talk about the walls, the foundations, the roofs, quality control, how they work together, systems working together, why you have to put certain things in certain sequences, why things have to be built in a certain way. Quality control is my most favorite word in the history of the world, because quality control is making sure that what we're doing works and what we're doing is appropriate and to the degree that we want it done. Obviously, the students will be working with different materials. They're going to learn about all different things. How many different screws can you use to build something? There's so many different heads, different tips, different lengths. Why is the thread count different on certain screws? Why do certain screws only work with sheet metal and not wood? They're going to learn all these individual things and see how large of a world there is in engineering and construction. Safety obviously will be the #1 key in all of this. Safety is to make sure that we give everybody that has 10 fingers and 10 toes back with 10 fingers and 10 toes. And then we get to building. So we should have from week 7 to week 18, which is 11 weeks. It's in the middle of if it's in the beginning of the year, it's going to be in the middle of Christmas and Thanksgiving, but we should have 11 weeks to figure out how we're going to build this thing. Between 2 classes working together, we're going to have 11 weeks to build the structure. And if we can't get the structure done, the fail-safe is we at least get the skin and the actual framing of the structure done, because that will give them a very good understanding of how things work. But can we get the construction done in 11 weeks? They're going to learn how to do troubleshooting and problem solving. When you measure this and you don't do the right thing, this is what you get at the end. And what do we have to do to change that? So when we do wall number 2, we don't have the same problem, right? If you have an issue, can you correct it so you're not making the same issue over and over again? Definition of insanity. We're trying to do things the correct way. It's not about making mistakes. It's about not making mistakes repetitively, right? So that's the biggest thing anywhere you're going to ever work, is not making mistakes over and over and over again. And that's it. And the key really is going to be understanding how this class is going to work, understanding how all of this is going to tie together, and making sure that when they're done TED 3, which is Technology Energy Design 3, students walk out and they feel very competent about and confident about what they learned. And in the middle of all these things are going to be lessons and everything else, but ultimately we want this to be experiential. We do not want TED 3 to be just overloaded with work. We want this to be experiential, where they're getting the concepts and the ideas. So when they leave, they have a very good idea of what field they like, what they don't like, what are the parts of that field they like. Hey, none of this has anything to do with construction. It's got to do with the processes. Construction just happens to be the lens we're looking through. When they leave here, they might like quality control. They might like quality assurance. They might like all of the different things, troubleshooting, problem solving, and they can do that in construction. They can do that in computer technology. They can do that in engineering. They can do that in science. They can do that in all different things. We want to make sure that our students leave better than when they came in, not just students with a bunch of information that they may or may not use. So I appreciate it. Thank you.